So another technique of integration that will work on integrals involving trigonometric functions, especially powers of trigonometric functions. No? So again, integrals involving trigonometric functions that cannot be handled by basic integration formulas are often evaluated by using the technique called integration by trigonometric transformations. In order to apply this technique, certain combinations of trigonometric functions must be properly transformed by using appropriate trigonometric identities. So the following trigonometric functions lead to different cases of integral forms. For instance, you have tangent to the n, cotangent to the n, tangent to the m, secant to the n, cotangent to the m, cosecant to the n, sine, cosine, 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 and sine, sine. So, and then also, you have a product of, let's say, powers of sine and cosine and or cosine. Okay? So, again, we call this integration by trigonometric transformation. So we have integration by trigonometric transformation. Okay? So here we will be considering the following, no? So consider the following. Consider the following. We have tangent to the n, let's say to the nu. Then we have cotangent to the nu. What else? You have, let's say, tangent to the mu, secant to the nu. So that combination, we have combination of cotangent to the mu, cosecant to the nu. Look at the partners, cotangent, cosecant, tangent, secant. And then also we have powers of sine and cosine. Like for instance, sine to the m, u, cosine to the nu. So these powers, combination of linear sine, let's say mu, cosine mu, with the same argument. We have sine of mu, sine of mu, and nu. The other one is n. So this combination. And then the last one, we have cosine, cosine of mu, cosine of nu. So if you encounter powers of these trigonometric functions, most of the time, integration by trigonometric transformations works, okay? And this powers of trigonometric functions lead to different cases. So we have, I will be considering 6 cases. Okay, let's start with case number 1. So case number 1 or type 1. Some books call it type 1. If the integrand takes the form of integral of sine m sine to the m u, then multiply to cosine to the n u. So this combination of powers times the differential of the argument, meaning of u, with the condition that either m or n is a positive odd integer. Is a positive odd integer greater than or equal to 3. Then you can use the following identities. Then use sine squared u equals 1 minus cosine squared u for the transformation that you are going to have, or cosine squared u, depending on what to be transformed, equals 1 minus sine squared u. Okay, guys? So that's what you're going to use. These identities for this combination, as long as the condition is what? Is satisfied, then you can use any of these, no? Depending on to be which is to be transformed inside, okay? This integral. So I'm going to give to you the strategy in the examples, because if I'm going to have the procedure, then it is still hard for you to memorize them, no? So let us have a particular example. So let's say we are asked to evaluate still alive, guys? Guys? Guys?
Yes po, sir.
So let's say we're given this integral. So I lost the beautiful integral. Yeah. I think I need to keep this. This beautiful one. It's not easy to make a nice one. Select and then shape, make it thicker by making it at least 2 the thickness, and then make a little higher. Okay, so let's say we're given this integral sine cubed 3x, sine cubed 3x. Okay, so this is under this case 1. Why? You have actually a combination of sine, the exponent is 3, and that is an integer. And the other power, which is cosine, is not present because what? The exponent is 0. Okay? The requirement is just that we need one of them to be at least what? One of them at least having positive odd integer exponent. Okay? So this is an odd, so it satisfies this form. Again, the reason why there is no cosine, it means the exponent is 0. So the odd power will be the one to be transformed. Okay? So what you do is to split this into what? Into a linear sign, and that linear sign will serve later as part of the differential. You're going to combine that linear sign to be segregated. You're going to include that with the dx. So meaning, you are going to form quadratic power of sine, no? So we have sine squared 3x, and then the linear that I'm going to segregate will be part of the differential because I'm going to transform sine squared in terms of cosine squared. And then this linear sine 3x dx will be part of the differential of cosine later. So again, this is to be transformed. Yeah. Transform. How to transform this? We use identity. What identity, guys? What identity? 1 minus cosine squared u. But our u here is 3x. So we now have integral of one minus cosine squared 3x. So we are now able to transform sine squared 3x in terms of this identity, in terms of cosine. And then the next step to do is to distribute this sine 3x dx inside to come up with two integrals. Okay? So the first integral, we have sine cubed 3x dx, which can be handled by integration by trigonometric formula. No? So we have sine 3x dx, and then minus the second integral, we have cosine squared 3x sine 3x. So this is GPF, okay? Can be handled by general power formula for integration. U to the n, this is n, and this is the potential du, no? We'll just be fixing later. Okay? What is the integral of the first term? I'm going to put 3 balanced by 1/3. Am I correct, guys? So I'm going to put 3 balanced by 1/3. So we get integral of but later you must be familiar with what? With mentally introducing a factor, okay? So, sine of 3x. I put 1/3 outside because I am planning to put 3 inside. So that this is sine u du. And then for the next one, I'm going to put -3 because the derivative of cosine is negative sine. Okay? Then derivative of 3x is 3. So this is now plus. I'm going to put -3 balanced outside by -1/3. So we now have integral of what is this? So we have cosine squared 3x, then times negative 3 sine 3x dx. Okay? Okay, guys? Can you follow, guys? Guys. Guys.
Yes, po, sir.
Okay, so what is the integral of the first term? Negative 1/3 by negative, integral of sine is negative cosine times 1/3. So cosine 3x plus this is power formula. Integral of u to the n du. So u to the n plus 1, that is now cosine cubed of 3x over 3. Then plus c. So let's just simplify the coefficients. -1/3 and then cosine of 3x for the first term. For the second term, we have 1/9. Then cosine of what? Cosine cubed of 3x plus c. That's it. That's the integral. So this is case 1 under integration by trigonometric transformations. So that is combination of powers of sine and or cosine. So in this case, there is no cosine. So because of what? So because cosine has the exponent 0. And take note, at least one of them is an odd. If two of them are odd, you choose the smaller exponent to be transformed because it's not easy to expand later if you're going to have bigger exponent. Let's say between 3 and 7, because both are odd, you're going to choose 3 to be transformed. Okay? The power of sine or cosine with exponent, let's say 3, that is the one that is to be transformed. If let's say you have 7 and 6, you have no choice but to choose 7 because the one that is to be transformed, power having an odd exponent, not the even one. So you're going to retain the even power. Okay, guys? Let's have another one for you to be able to understand it well. So let's say we're given this integral and I think we need much space. So we have what number now? 2? 2. Cosine, let's have one. Cosine to the 5th 2 theta d theta. So again, this is add power of cosine. So under case 1, there is no sign, meaning the exponent is 0. Is that clear, guys? Guys. So this is equal to express this as what? quadratic power, and then the excess linear cosine will be part of the d theta. So we now have integral of cosine. So quadratic, I'm going to form quadratic cosine squared 2 theta. So what will be the exponent to complete the 5? Because I'm going to segregate one cosine. So how many more for the exponent to complete the 5? Guys, cosine 2 theta d theta here. So just 2, no? Am I correct, guys? Because if I am going to raise this to 2, so it is 2 to cosine to the 4 times cosine, cosine to the 5th. Remember, our goal is to come up with quadratic power because what because what we have in the transformation is a quadratic sine or cosine. Okay? So, and this is equal to, let's transform this now, guys. So we have this integral. What is the transformation that I'm going to have here, guys? So let me write here. This is to be transformed. Transform. Okay? So how to transform? So you have to shout, let's vault out. Vault out daw. So we now have 1 minus sine squared. So that's the identity or the transformation that we're going to have there. Quantity squared. Then multiplied by cosine 2 theta d theta. Next, we have to expand. And this cosine 2 theta d theta will serve as the differential later. All you have to do is to fix by the necessary numerical coefficient that is that will require for this, no? So we have, let's say now expand, guys. What's the expansion? Guys, still alive, guys? 1 minus 2 sine squared 2 theta plus sine to the 4th 2 theta, then times cosine of 2 theta and d theta. Okay? So this is now integration term by term. So what is the integral of the first term? So we have integral of cosine 2 theta d theta. So let's have this is cosine 2 theta d theta. You can do that mentally by putting 2 here, balance outside by 1/2, minus 2 integral of so let's have this integral, but I have to put 2 in front. So we have 2 here, sine squared 2 theta times cosine 2 theta d theta. Okay? Then the last integral, what's the last integral? Plus sine to the 4th plus sine to the 4th 2 theta times cosine of 2 theta d theta. Okay, guys? Anyone who wants to give me the answer for the integral of this? Do it mentally. Guys, what is the integral? I put 2 balanced by 1/2. What is now the integral of cosine 2 theta? Guys,
Negative present.
positive 1/2 sine 2 theta. What about this? I'm going to put 2 balanced by 1/2. So meaning this 2 is needed inside, no? So no need for 2 outside. So what is the integral of sine squared 2 theta? I put 2 here, cosine 2 theta d theta, and no more 2 here. So u to the n du. What's now the answer? U to the n plus 1 over n plus 1. Okay, this 2 outside, I put it inside because that is needed as the differential of sine of 2 theta. Okay, guys? To complete. So that is GPF. The last one is also GPF. Okay? So what will I put inside, guys? What will I put inside? Guys, what will I put inside? 2, no? Balanced by 1/2. So I will put 1/2. What's now the integral? Do it mentally. U to the n plus 1, 2 theta, sine to the 4th 2 theta, magiging what? Sine to the 5 to the 5th 2 theta over 5, no? Plus C. That's it. Let's just simplify the numerical coefficients of the last term. 1/2 sine 2 theta. Yung introduction of constant inside, you can do that mentally, no? So by this time, if you are already in the technique, you should know how to handle basic integration mentally in most of cases, okay? 1 over 10 here, sine to the 5th, 2 theta plus C. Any question, guys? Guys? And then the last one, I don't think we still have much time, but I'll just give the problem, then you can continue and post it in our incentive. I-post nyo lang doon. I will post it there. Kaya lang sa midterm na to, no? Okay? So let's say I have this one, sine to the 7 of y, this 7 y cosine to the 6th y dy. This is under case 1 because there is an add power. Am I clear, guys? Add exponent. Okay, guys, why is it under case 1? There is an add. Again, if there are 2 add powers, which is to be chosen? Which is what are you going to choose? What are you going to choose if there are 2 add powers or 2 add exponents? Can you choose any? Actually, you can choose any, but choose the smaller one. Because if you're going to choose the bigger one or the larger exponent, it is difficult to expand later. Okay? You will regret. So if you don't take my suggestion. Is that clear, guys? So what you do, we have integral of, I will make it fast, sine, it's already time. Do you have class after this, guys? Guys? 3?
Meron po, sir. Meron po, sir.
Okay, you may go now. So you have 1, then copy cosine to the 6y. So this is y. This is 6 only. So the other cosine is here. Yeah. This is what I'm going to transform. Okay, guys? So you can continue this. So again, you have to segregate one linear from the add power of sine or the one that has an add power. Okay? And then you just copy the even power and this is what you're going to transform. So this part. Okay, guys? Don't forget for your attendance transform. You need to transform this. That is to be transformed in terms of 1 minus cosine squared y. And then you have to expand to the third, the binomial form. Okay, bye guys.